All right, our first example here. Let's take the derivative of this function, 3x squared times sine inverse of x. There's the product rule just waiting to happen. So we will use first times derivative of the second plus the second times the derivative of the first. So we need the first, copy paste, times the derivative of the second, the first, times the derivative of the second. The derivative of sine inverse of x is 1 over the square root 1 minus x squared, times the derivative of x, technically that's just 1, first times the derivative of the second, plus the second, copy paste, times the derivative of the first. And if all you're asked to do is find the derivative, that's it. If you need to simplify that for some reason, you would, but if that's all you're asked to do, that's all you need to find. That's the derivative of that function with the product rule. Suppose we have x to the fourth times tangent inverse of x. This is x to the fourth. All right? So this implies the derivative. It is the first, copy paste, times the derivative of the second. I probably could put this in parentheses to help. First times derivative of the second. So what's the derivative of tangent? That's 1 over. Remember, tangent does not have the radical because the derivative of tangent is secant squared and the radical gets squared away. So that memory device should help you. Also, tangent is positive as opposed to sine is subtraction. Do we see the difference here? So make sure you have the difference. First times the derivative of the second, the derivative of the inside is 1. Plus the second times the derivative of the first. And if all you're asked to do is find the derivative, that's what you just did. All right. Do we know how to play quotient rule? Yeah, I think we know how to play quotient rule. Suppose we have tangent inverse of x over x squared plus 1. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over denominator squared, and thanks for coming out. All right. Do we know how to play chain rule? Well, that's the statement of the derivatives that you have in your list of basic forms, so we ought to. Suppose f of x is secant inverse of 5x to the third. All right? Now, remember, in this scenario, the part of u is being played by 5x to the third. Everywhere we see a u in the basic form, that's where 5x to the third goes in. So, the derivative of secant is 1 over, we need the absolute value of the expression. If you do not have the absolute value, then that result is not correct. Those must be present. Times the square root of. And then we need u squared, so this is 5x to the third squared. You don't need to simplify it. That's 5x to the third squared is u squared minus 1. But then we must multiply by, because the chain rule says I need to multiply by the derivative of the inside. So that's 15x to the second, and that's the derivative we're looking for. So what's left to do is to practice that over and over and over again. If the text asks you to compute the derivative of cosine inverse or cotangent inverse or cosecant inverse. You may ignore those. I'm not going to ask those of you. I'm not going to expect those of you. You rarely, if ever, encounter those in Calculus 2. And so for our purposes, particularly this semester, we're going to let that one go. I'm going to hold you responsible for using secant inverse, tangent inverse, and sine inverse.